The purpose of this video is to introduce you to the At-Risk Excel Developer Kit, or more simply, the At-Risk XDK. A companion PDF file, At-Risk Automation Guide, introduces the At-Risk XDK in some detail, but you might prefer to watch this video for a quick start. This video assumes that you are already familiar with the goals of At-Risk and its various features, and that you know how to implement these features through the user interface, that is, through the At-Risk ribbon and the At-Risk dialog boxes. Now you can take the next step toward becoming an At-Risk power user by learning how to automate this process with Visual Basic programming. Granted, it is not difficult to change settings, run simulations, create graphs and reports, and other tasks through the At-Risk user interface. Here are some possibilities. I'll change the number of iterations. I'll turn this off. I'll start a simulation. I will add a statistics function. I could add more of these. I will browse the results. I will copy this graph, paste it into Excel, and you can do other things. However, just imagine that you can make all of this happen by clicking a single button, as I will now do. Here is the same model, and I will click a button and watch what happens. There are the statistics, there's the graph, the simulation was run. Even the settings were changed. This is exactly what you can learn how to do with the At-Risk XDK. You can learn to write Visual Basic programs that make everything happen. One benefit of these programs is that you can automate tasks that you perform on a regular basis, thus saving you from repeating the same steps over and over. A second benefit is that you can create applications for colleagues or clients who understand the reasons for at-risk but are not familiar with the way it works. In this case, you can enable these colleagues or clients to reap the benefits of at-risk simulations by simply clicking a button to run your programs. To get started, you need some basic knowledge of programming for Excel. Its programming language is called Visual Basic for Applications, or VBA. Thousands of Excel users write VBA programs on a regular basis to automate Excel. The primary reasons are that VBA for Excel can be used to create powerful applications, and it is relatively easy to learn. The key to programming with VBA for Excel is the Excel object model, part of which you see here. The object model is a list of objects, where objects are simply the things you manipulate in Excel, such as ranges, charts, worksheets, workbooks, and many others. Each of these objects has a list, often a long list, of properties, methods, which are also called functions, and events. For example, here is the list for the chart object. A property describes an object, like an adjective. A method or function is something you can do to or with an object, like a verb. And an event is something you can respond to when it occurs, such as the opening of a workbook. The properties on this screen are indicated by hand icons. The methods or functions are indicated by the green brick icons. And the events are indicated by lightning icons. It turns out that events don't play a large role in VBA programming for at-risk, so they won't be discussed any further here. As you can see, a chart object has a name property, the name of the chart, and many other properties. A chart object also has a delete method, which allows you to delete a chart, and it has many other methods. By learning the Excel object model, you can make a VBA program do virtually anything you can do through the Excel user interface. Objects also come in plural and singular versions, a concept that is crucial for Excel and at-risk programming. For example, there is a singular chart object, which refers to a particular chart, and there is a plural charts object. which refers to the collection of all charts in a workbook. These are very different concepts. For example, you can add a chart to the charts collection, or you can count the number of charts in the collection. But you can only fine-tune the properties, its axes, plot area, titles, and so on, of a specific chart. At Risk uses these concepts for its own purposes. It has its own object model, as you see here, and its objects have their own properties and methods. For example, it has a risk simulation object. This object has a settings property, which allows you to change many simulation settings, and it has a start method, which allows you to run a simulation. The object model also has singulars and plurals. Here is an example. The risk fit definition object, which is singular, and the risk fit definition collection object, which is plural. Once you learn these, you can use the same Visual Basic language to automate at Risk that you use to automate Excel. Fortunately, the learning process is not difficult, especially if you have some programming experience in any programming language. Indeed, one goal of this video is to convince you of the ease and power of automating at Risk with VBA. Let's get started. The at-risk model you see here, the same one you saw earlier, is a simple net present value example. It contains distributions for the yearly costs and revenues in the blue cells, and these lead to the NPV, which has been designated as an at-risk output. A VBA program has been written to change some simulation settings, run the simulation, report several summary statistics of the NPV output, and create a graph of the NPV output. Again, you can see how this happens when I click the button to run the program. Everything happens automatically. Now let's see what makes this work and how you can learn how to do it yourself. The first step is to get into the Visual Basic editor, which is where you do your programming. The quickest way to get there is with the Alt F11 key combination. Here is the Visual Basic editor. It has a menu bar along the top, a project pane along the side, which lists all of your open files or add-ins, one or more toolbars along the top, and the big code window where you write your program. The earlier discussion indicated that VBA programs for Excel take advantage of the Excel object model. To see how this works, you need to understand library references. I will select the first program file in the project pane and then select references from the Tools menu. By default, several references are checked. Among others, these include the Visual Basic for Applications library and the Excel Object library. These references suffice for any program used to automate Excel. However, they don't suffice if you are automating at Risk. Therefore, the first step you should perform in any program that automates at Risk is to check two references, Risk XLA and Palisade at Risk 6.2 or whichever version you are using for Excel Object Library. Actually, you see a third reference for Risk Optimizer. If you are automating Risk Optimizer as part of an overall at-risk model, you should check this reference as well. The next step is to create a module for your program. A module is like a big piece of paper where you write your VBA program. You can open a blank module from the Insert menu. Normally, you then start typing code. To save time here, I will copy the code I have already written into the module and then explain it. Take a look at this program. It is actually called a subroutine. Subroutines always start with a subline followed by a descriptive name, and they end with an end subline. The lines in between do the work. You shouldn't have much trouble understanding what this subroutine does. The green lines that start with an apostrophe are called comment lines, and they are useful for documentation. But even without these comments, the code should be fairly self-explanatory. Starting with risk simulation settings, a few simulation settings are changed. This block of code, called a with block, is very common because it leads to compact, easy-to-read code. Here is the with block. Everything that starts with a period inside the block implicitly has risk simulation settings to the left of the period. So you would read the num simulations line as the number of simulations setting of the at-risk simulation is 1. The risk simulation start line runs the simulation. It's that simple. The outer with simulation results block, starting right here, accesses the results of the simulation. There are two types of results. The with get simulated output of NPV block, starting here, provides access to the summary statistics of the NPV output. These are placed in cells C19 through C22. The graph distribution of NPV block, starting right here, creates a graph, actually a histogram, of the NPV output distribution, and it sends an image of this graph to the active sheet. The last 4 numbers determine the position and size of the graph. There are several great things about this code. First, it is very compact. A small amount of code accomplishes quite a lot. Second, it is very readable, which makes it easy to learn. Finally, it can be reused. If you need to do something similar for another at-risk model, you can paste this code into a new module and tweak it slightly as necessary. As you start writing VBA programs for at-risk, you will find yourself copying and pasting a lot of code, either from the example files we have provided or from your own examples. There is no reason to reinvent the wheel if you don't have to. Later videos will go into more depth, but here are some ways you can start learning how to code for at-risk. First, you can examine the code in the accompanying at-risk XDK example files. As just mentioned, you can often copy all or parts of this code and then modify for your own purposes. This beats starting from scratch each time. Second, you can use the object browser in the Visual Basic editor. To do this, make sure a file with at-risk references is selected in the project pane. Then click the Object Browser button or press the F2 key and select At-Risk OL6 from the Libraries drop-down list. On the left, you see all of the at-risk objects, those with the red, blue, yellow icon, like this. When you select any of these objects, you see a list of all its properties and methods on the right. By selecting any of the properties or methods, you see some help on syntax at the bottom of the screen. By the way, all of the items on the left with double yellow icons are called enumerations. Each of these provides a list of meaningful names for a particular at-risk property or setting. For example, the risk statistic type enumeration contains all the statistics you can request. You would refer to these names in your code. Back in Excel, you can access extensive help on the at-risk XDK from the Developer Kit XDK drop-down list under Help. This help includes the PDF automation guide mentioned at the start of this video, extensive reference materials for at-risk and Risk Optimizer, videos including the one you're watching now, and many XDK example files. Fourth, the accompanying Excel file, Risk XDK Object Model Diagrams, that you see here, distills the many at-risk objects, properties, and methods down to the few you will probably use most often. It also helps you learn the hierarchies in the at-risk object model. Here is a typical example for learning about at-risk graphs and the way object model hierarchies work in general. Essentially, you drill down a hierarchy to get what you need. In this case, you start with the root risk object. This is a reference to at-risk itself. Then you use its simulation property to return a simulation, actually a risk simulation object. You can use its start method to run a simulation. After this, you can use its results property to return a risk sim result collection object, which is a collection of results. From this collection, you can use its graph distribution method, for example, to return a risk graph object. Once the risk graph object has been accessed, you can use its properties to fine-tune the graph or send an image of the graph to a worksheet, for example. The sample code you see here illustrates this process. Obviously, the code is quite a bit simpler than the explanation I just provided, but it does help to understand exactly what is going on with the objects and their hierarchies. To conclude this video, I will show how you can make it easy to run your program. You can run it from the Visual Basic Editor, but chances are your users won't want to go there. However, you can make it easy for them by inserting a shape into your model worksheet and attaching your macro to it. I'll do this now. Then you can add some meaningful text to the shape. Finally, you can test it out by clicking the shape and feeling the power of automation. When you save this file, you must save it as an XLSM file, where the final M stands for macro. This is because the usual XLSX files are not allowed to contain macros. Now that you know the basics of programming for at-risk, we hope you are motivated by the ease and power of VBA and the at-risk XDK to watch the other videos in this series. Specifically, we recommend that you watch the video on IntelliSense to see just how easy it can be to write programs for at-risk.